Good morning, here we are again. And Sophia, I need to click. See, that worked. Thank you. Innovation is hard, right? So that's why I love working with Kiefer. They take risks, they try new things, they do it for the first time. And yeah, sometimes, that doesn't work at the first time, but I'm sure they will get it done. I wanted to start with a little bit of a video on innovation. So let's have a look.
It began here. The first industrial revolution. Watt's steam engine and the mechanized loom introduced automation and the advent of factories. And industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator, and Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot gyms, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began.
So innovation at work, and in that video you saw a lot of European examples, and I think the mission that I have together with Christos is to make sure that we also feature Greek projects, right? So help me a little bit to get that done. I'm going to talk today about AI factories for sovereign intelligence, because it's really important that we will be masters of our own journey when it comes to AI. And I'm heading up the enterprise solutions business at NVIDIA for Europe, Middle East, and Africa, and the topic of AI factories fits into that remit. Now, if you feel a little bit confused on the topic, or if you think, wow, this is going really fast, what's happening in the AI space, you're not alone, right? I've been doing this now for 10 years, and also I myself think, wow, it's going faster and faster. And just this year alone, as you see how fast we're going, the geopolitics, the massive investments, the leap forward that some of the countries are taking, they are breathtaking. But this is a defining moment where each and every one of us should ask, are we falling behind? Are we capturing the opportunity? Are we moving forward with the same speed as others are going? Now, sovereign AI is not just about having the technology. You need to have this complete set of pillars to support your sovereign approach. And this is our vision on it. So you need to have, of course, government support and a great framework to get things happening. You need to preserve your own culture, right? You don't want to ship off your data to someone else and then buy it back. No, you want to train it locally. So that's why we appreciate efforts like Sophia. But you also need to nurture a strong ecosystem, right? You want to have your startup community, you want to have strong research, you need to have the upskilling of your workforce. How do we help people with the transition as we move from one way of working to the next? And you need to have your own models and data. That's quite important. But by the end of the day, the foundation, you need to have the technology in place, because AI is a technology play. If you don't have the instrument, then this will not work. And the parallel with the Industrial Revolution works really well, because if you think about it, if we go back, you saw that some countries really captured the opportunity, and they leaped ahead. And not for a little while, but for centuries after that, right? They stayed in a strong position. While there were other countries that fell behind, and they had a really tough time catching up. We're in that same spot right now. It's happening as we speak. And it's only fair to say that we see some countries moving very fast, right? And others being a little bit indecisive where they want to go. This is your defining moment. Now, today it's not about steam, it's not about just producing electricity. We have a new foundation for this new AI industrial revolution. And the cornerstone of this momentum is the AI factory. And the AI factory is not a data center. The big difference with a data center is a data center just houses computers, right? It costs money. But an AI factory produces something. It produces intelligence. Your data goes in, your local data goes into the AI factory together with energy, and then we produce units of intelligence, which we call tokens. Christos was already talking about it, but we produce tokens. And these tokens, they unlock all this opportunity that you see here on the screen, whether it's in science, whether it's for the enterprises that you have, whether it's in healthcare, or of course in manufacturing capabilities, but it's unlocking trillions of economic value. AI factories are the essential foundation to move forward. And what do they unlock? Well, if you have that in place, it will unlock economic growth, right? So making sure that you have a local ecosystem that develops, that you keep up with all the innovation, and at the same time that you also have attractive jobs and startups. Else talent will move somewhere else, where those factors are already in place. Then there's also an opportunity for the public sector itself. The government also has an opportunity, if you're in government, to apply AI to make our lives easier and also to keep us safer, right? We are currently in a situation of geopolitical unrest. Also, this technology is important, right, to safeguard our own national priorities. And then in the middle, scientific breakthroughs. And so in the past, we all know that you need to have instruments for scientific breakthrough, whether it's a microscope or a telescope or a particle accelerator. But the new instrument for scientific breakthrough is the AI factory, right? You either have it or you don't. And all of this together underlines why this is so important for a nation to have this all in place. Now, what is an AI factory? An AI factory is so much more than just having a chip. The AI problem in itself is much larger than one that one can address with a single chip or an accelerator. It requires a complete orchestration of infrastructure and software. And so here on the screen you see an example of a Blackwell-based AI factory. And sure, we make GPUs, and GPU you can see as the rocket engine of an AI factory. That's a Blackwell chip, but it requires 7 chips we have developed. So we specifically engineered a CPU, not a GPU, a CPU, to take care of these loads. Then one of the most important things probably for an AI factory is the communication. So there's a lot of network technology, because you do not need a single chip or one compute node. You need to combine thousands of them. And so networking becomes very critical. And so this is what we do at NVIDIA. We do extreme co-design, where we take all of these elements. We're the only company that has all of this under one roof. And we orchestrate this so that this can take on the world's largest AI challenges to do the computation on that. Now, having the infrastructure is one thing, But see this as the engine. If you don't have the transmission, you will not have a lot of traction. And the software that comes on top, the software that we develop, think of it as toolkits, as building blocks, maybe as Lego bricks, if you will, that developers, researchers can reutilize to build their own things. So if I want to build my own local language model, you don't need to reinvent the wheel. You can take some of the Lego bricks and then add your own IP on it. If you want to create a humanoid robot, you don't need to reinvent the navigation and so on. So this is what we do with all those building blocks. And at NVIDIA, we're an engineering company, right? So most of our people are engineers. And 80% of our engineers are working on the software side. And that makes all the difference, right? Because you can have the technology, but the question is, how do you apply it in the real world? And that's where we put all our effort. So this is an AI factory. Now, turns out that an AI factory is very good in training. In AI, we have two concepts, right? The training and the inferencing. And the inferencing is if we take a model that we have trained and then we start serving out the results. Turns out that inferencing is an even harder challenge than just the training part. Training, large job that you do up front. The inferencing nowadays, and I heard Chris's talk about it, that in the latest Sophia model, it's about reasoning as well. And I think you all have probably tried it already. If we generate an answer with traditional generative AI, listen to me say traditional generative AI just exists for 2 years, right? Let's say I want to go for dinner tonight in Athens. I say, give me 5 nice restaurants in Athens. Within a second, I'll get an answer, and it might be okay. Now we go to reasoning AI. So if we go to reasoning AI, we use all the data, we give it more compute time. And the thing that will happen now is that it will probably start by asking me a couple of questions. What do you like? How much time do you have? What is your budget? In which area are you? And then it will go off for 20 minutes to think about it and come with the best answer. We can combine it with agentic AI, that it completes this task for me, and even book the table for me. And so we go from a nice answer to a solution. Now, I just used the restaurant example, but we could do this in the medical space to come up with medicine candidates and so on. The thing, however, to keep in mind is that if we think about this AI factory, where we produce tokens, suddenly we need 100 times more tokens to be produced to come to a good answer versus a fast answer. So that's why it's necessary to think a little bit about the AI factory. And here you see a framework that we have developed to support this new innovation that you will find in inferencing when we think about reasoning, if you think about agentic. And here are a couple of innovations to drive it at scale, to meet all the requirements that these models have. It's very, very complex to do this. And also, when we are scaling these models, we need to think about the return on investment, right? All of this needs to make economic sense as well as we're scaling to, let's say, the whole Greek population. So this is a framework that we created to support exactly that. And these innovations, they exist in the technology itself, in that AI factory that you saw earlier. There is a benchmark out there, because there are many people working on AI technology, and there's a benchmark out there called MLPerf. It has been set up by the industry to measure the performance of AI factories and AI technology. And since this benchmark was created, we have won each and every iteration of the benchmark, and every time they make it a little bit harder for us. So this is one of the latest tests that we have in the benchmark, and this is all about how can you drive inferencing performance, the thing that I just mentioned. So this is an independent measure of how you can perform. And we came up with an idea to introduce new innovation in the inferencing. So there are 2 things. This hardware innovation, as we go from one technology called Hopper into a new technology called Blackwell. And then on top of it, we do this software innovation. And the addition in performance is dramatic. So if you were on the previous technology, the largest supercomputer in Greece, for example, is on the Hopper technology. As we move into Blackwell, suddenly you can see that we get like a 3.8 factor of speed up. But now we do our software part. So I said 80% of engineers are on software. And then you get this green part on top of it in the performance. So you get a 5x speed up. I say this lightly, but if you think about the history of IT technology, you never make 5x jumps in one generation. And so if you're wondering, why is it going so fast with AI? It's because of this. Because suddenly, something that you could do today, you can do it 5 times smarter or bigger or faster than we could do 1 year ago. That's why you see all these crazy breakthroughs happening right now. So a little bit complex story, but I just want to make you realize why it is so important to keep the pace. And then there's also the cost, right? By the end of the day, this requires massive investment. And so the cost per million tokens that we need to produce in an AI factory is going down like nothing before. So the energy consumption, the performance, and the cost, they are all optimized. So you see a win-win happening right now. And this is also causing all of these breakthroughs and why you see these use cases getting larger and larger. It becomes very affordable to roll out big models throughout the nation. And it's even so far now that if we look at alternative technologies, that the performance that we bring forward with our AI factories, the performance is so high that it outpaces all alternative technologies that you see out there in the industry. So even if alternative technologies would be free, they're so limited in performance that it makes more sense to invest in the new technology because the potential is much higher. And so some of you might be familiar with our roadmap and that we went to a 1-year cadence of introducing new technology. And now you understand a little bit why by the examples I just shared, because the jumps that we can make from one generation to another are absolutely massive. And it's not just about the GPU, but across that whole AI factory we keep innovating. And this is causing the fact that you see all these breakthroughs in science. This is the reason why you will see the robots becoming more and more advanced and why it's going fast. This is also the reason why you need to keep up as a nation, right? If you think I'm going to skip 2 steps, you will fall massively behind, right? For us at NVIDIA, this is the way that we compete in the market as well. This is not a secret. It's very open. It's accessible to everyone. And just by going really fast, it's very hard for the competition to keep up with us. Now we're tackling all kinds of challenges. When I started 10 years ago, we had GPUs. And we thought it would be really smart for the AI opportunity to combine all these GPUs together. So we went to the market, we said to our partners, why don't you do that? And they said, nah, I don't know. We don't think the AI opportunity is that big. We thought it's really big. So we decided to create complete systems, and we invented that networking technology that I mentioned before. Suddenly we had very fast systems which were enabling development of self-driving cars, or the first ChatGPT was enabled by that. But we noticed that the rest of the data center was not keeping up. Networking was too slow, storage and data was too slow, so we decided to create blueprints for data centers to keep up. What we found now is that the infrastructure is not keeping up. We don't see enough energy being available to power the latest technologies, or sometimes we see that the speed of construction is simply too slow. Now, if you know that I have a technology cadence of 1 year, there's no way that we can wait for 5 years on a data center that is ready to take this technology. So this is the effort that we are very focused on right now, is to make sure that every country is aware of what is needed to power the AI revolution, and that we share our best practices on how do you build this and how can you go as fast as possible. That's the reason why we're teaming up with the likes of Kiefer as well. How can we do this fast? And so we decided to create blueprints. How do you build an AI factory? What are our best practices? And we take it much further than just the data center alone, but this is also the power. How can you do this in a sustainable way? How can you use the heat that you generate and repurpose that? So this is a key body of work that my team is currently fully engaged with. How do we enable this and then in the smartest possible way, fast and sustainable? And I'm just going to show you a little bit of a video how we are taking some of the innovations that we have to do this a little bit smarter. This is a very complex view of all the processes that are included to create an AI factory. And I'll just show you a little bit how we automate this together with our partners. We create digital twins of the AI factory way before it's being built, and we can simulate the whole environment. What is it going to look like? What do you need? How much power is going in? By the way, today we need around 100 kilowatts per rack, and with the new technology that will be with us within 2 years, we can do 1 or 2 megawatts per rack. Now, the compute that you will get out of there will be much more than what you have today, so the systems become more efficient, but the data center just needs to be more condensed. And then also when the AI factory is in operation, then the AI can help, of course, to control it and to manage it. We also came up with some concept to do this in a modular way. So how do you create, again, this whole concept of bricks that you can put one after another and scale and go into new technologies as we go. And this is powering very large setups that you see today. Here are some examples that you have in the US, but also here in region. We just broke ground, for example, in Norway with Stargate Norway, which is also scaling up at least to 0.5 gigawatt. Okay, and let's move on. So how is it going in Europe? Because I have this message, of course, not only for Greece, but also for Europe. We need to speed up. We need to be the masters of our own destiny. And luckily, we see now European telcos stepping up and putting infrastructure in place. So in Italy, we were working with Fastweb. In France, we have Orange, Swisscom out of Switzerland. Deutsche Telekom, massive investment now, because this whole thing about manufacturing in Europe requires also to have the resources to develop AI for the manufacturing world. So you will see a big play that we have in that spot. Then there are all kinds of new European cloud service providers, because don't get me wrong, I love the hyperscalers. They make it so easy to have data in one place and to get started. But it's also good to have sovereign, national capacity. And this is also where we're looking with Christos to put, of course, also Greece on the map. And we're looking forward to next year to also have Greece here on the board. But sovereign capabilities with AI factories. And then Europe can be super proud about the strong research community that we have. And so we have a tradition of supercomputer centers, and you'll find GRNET here as well on the screen. And the really cool thing is that we're leading when it comes to sustainability in Europe as well, because we are implementing these AI factories at tremendous scale. But we also have the most energy efficient supercomputers in the world. There's a benchmark called the Green 500, and in Europe we're leading. So we have the AI factory, and we do it in a very green way. And so the world's most sustainable supercomputer is in Germany, based on on the Grace Hopper technology. But also in France and in the UK and in Poland, we have super efficient systems, all in the top 10. And then, of course, the European Union is stepping up as well with the whole AI factory program to put subsidies in place to stimulate the ecosystem to work together, and also to apply and to build some gigafactories at large scale. And this is very good, of course, but I also recommend you don't wait for it, right? Work in parallel. So it's good that the EU is doing this, and at the same time, as a nation, as industries, as enterprises, we need to step up as well to meet this. And if you would be looking at this map 2 years ago, I would say as a startup, as a researcher, you will be in trouble to find some resources to get your work done. If we look at it today, we see a big progress, and we see a 10x projection of resources coming available. Now, is that enough? I don't think so. And if you look at your local resources, I think we can use quite a bit more. But at least we're working on it, and it's ramping up if you compare us to other geos. Now, local politics has awakened as well, because in the past we saw very visionary programs, but the execution was missing. And this year, all of that changed. I think there's a sense of urgency now. There's a very big appetite to work closely with us. People realize that our sovereign AI play is truly that. We want to work with governments across the world. We want to democratize AI and make it available everywhere, not in just a few spots. And in the UK, we made a big play. We were received very well there, and there's a very vibrant startup community in which we decided to invest also strongly. Then this is about Germany. I mentioned the Industrial AI Cloud before, but we are collaborating closely together. We have France there, also multi-billion program into play. But every country can participate. We're working in Poland, we're working in Norway, we're working with those that are willing to move forward and also to invest together. And here is an example of a smaller country, which I think is a good benchmark for some of us. This is about Denmark. And Denmark put their national supercomputing AI capabilities in place a little bit more than a year ago. I was at the birthday celebration 4 or 5 weeks ago, and just the research that they have accomplished in 12 months is amazing. They did great work on quantum computing research. They have been working on material science. They have been doing great stuff on climate research. And so to see the contribution that it's making and also how to keep Denmark relevant is very, very encouraging to see that it's not always about just the biggest country, but it's for those that are willing to move forward. Now, I want to move to a final chapter here in my update, because I've been talking about what's happening today, and I want to talk about what is happening tomorrow. And tomorrow, I don't mean years from now. It's something that is starting now, a very big wave that will disrupt, I think, a lot of industries in Europe. When I started, it was all about perception AI, right? So medical system, great contribution. We saw the catalyst that generative AI had, and now we're in the phase of agentic AI. Many of you will be in early days of adopting that, and this will unlock the opportunity in enterprises, in governments, to do things in a much smarter way. But the thing that is happening right now is we see physical AI, and we think this will be massive. We think this will disrupt a lot in industry. The question is, why is it happening now? So NVIDIA, why do you think this is suddenly so important that I should be very aware of it? It's because there were 3 computers needed for this. We say this is the 3-computer challenge that exists for physical AI, for these robots to come in our domain. And robots can be any shape. It can be an industrial robot. We saw the humanoids. We saw the quadpeds already walking around here. But we, for example, built also self-driving cars. And that's just a robot with 4 wheels as well, right? So, and all these robots have the same challenge. Because turns out, just like a human, you can go to a university, but it doesn't tell you anything about the real life. We need to learn from the real environment. So, first we need to train them, the models. We do that in a big AI factory. The second thing is we need to deploy those models inside that car, inside that humanoid, and we need to have very capable target computer platform in there, which is highly efficient, but also very powerful. We have fixed that. The part that was missing was the simulation part, where we learn from the real world. And so think about that self-driving car. We wanted to learn about difficult environments. We wanted to learn about traffic in Athens, but we want to learn about snow in Athens as well, for the odd chance when it happens, right? We wanted to learn about glaring sun that comes really low. We wanted to learn about corner cases that they meet in traffic. So we simulate that in super high fidelity. And think about it, so we can practice all kinds of accidents and find the best possible outcomes. And now let's move away from the cars and think about humanoids and factories, right? You do the same thing there. You train, you simulate, and once it's ready, you bring it to the real world. And these computers, they have a different shape and form. So on the left, you see the one that is used in AI factories to do the training of the model. In the middle, you see the kind of setup that we use in AI factory for simulation. And this is actually what is sitting inside of a robot. It's called Jetson, or in a self-driving car. Now, at NVIDIA, we have our own problems that we address with physical AI as well. You know, our technology is in strong demand. You know that we need to put our production across the globe as well. So we thought, if we need to build new factories, why don't we take all of this technology and put it in our new factory so that we can go faster and we can produce more. And so I have a little video for you where I show you how we use physical AI in the factory that we're running together with our partner Foxconn.
Foxconn is building a state-of-the-art robotic facility for manufacturing NVIDIA AI infrastructure systems. With labor shortages and skills gaps, digitalization, robotics, and physical AI are more important than ever. The factory is born digital in Omniverse. Foxconn engineers assemble their virtual factory in a Siemens digital twin solution developed on Omniverse technologies. Every system, mechanical, electrical, plumbing, is validated before construction. Siemens Plant Simulation runs design space exploration optimizations to identify ideal layout. When a bottleneck appears, engineers update the layout, with changes managed by Siemens Teamcenter. In Isaac Sim, the same digital twin is used to train and simulate robot AIs. In the assembly area, FANUC manipulators build GB200 tray modules. Bimanual manipulators from FII and Skilled AI install bus bars into the trays, and AMRs shuttle the trays to the test pods. Then, Foxconn uses Omniverse for large-scale sensor simulation, where robot AIs learn to work as a fleet. In Omniverse, Vision AI agents built on NVIDIA Metropolis and Cosmos watch the fleets of robots and workers from above to monitor operations and alert Foxconn engineers of anomalies and safety violations, or even quality issues. And to train new employees, agents power interactive AI coaches for easy worker onboarding. The age of US reindustrialization is here, with people and robots working together.
So, in time to wrap up on this one, we've spoken about sovereign AI. We think every nation should be the master of their own destiny and their own data. We've spoken about the different waves of AI, and this wave of physical AI is coming and disrupt everything very fast. And we're super proud to team up with Kiefer, that is playing with us in all these domains, from AI factory into the physical AI space. And again, my invitation to you, we're keen to team up with you. The whole team is here, so please start this journey with us today. Thank you so much for your attention.